Alright, so this is 5.2 homework, problem solving, and we're going to do these optimization problems. And so the idea in optimization problems, it's a four-step process really: picture, equation, solve, and test. We really won't need to solve to test, because we'll do this sort of in the solving part. So here, number one, we want to create a picture. So it says, if you need to enclose a rectangular area with 600 feet of fence and one side is along a barn, what is the maximum area you can enclose? Okay, so I have a rectangular area here, and I have 600 feet of fence. That's perimeter stuff, so I'll make sure I write that down. The perimeter is equal to 600 feet. One side is a barn, so along this side, doesn't matter which side you put it on, but I'll put it along this side. I have a barn. And I'll probably label this X, this Y, and of course that's X. I don't need to label this side because that's the barn, and well, that's feet. And what do I want to find? We'll find the max area. Okay, so there's my picture, and now I come up with my equation. Right, so my formula, and it's what I'm trying to maximize, what I'm trying to optimize, right? Trying the best value, and that's the area. So I write A equals, and that's X times Y. And the idea is I'd like to graph this, and if I can graph it, then I can point to the maximum. But the problem is I don't have one letter here, I have two, X and Y. But that's where the 600 comes into play. So the 600, that's the perimeter, so you just add up the sides. So I have X plus Y plus X. So I have two X's plus a Y, and then I can solve this for Y, so I move over 2x, so subtract 2x from both sides, and I get 600 minus 2x equals Y. Right. And what I simply do is I plug this in for my Y, because Y is equal to 600 minus 2x, so A is equal to x times 600 minus 2x. Now I have A as a function of one letter, of one variable, and so I can come over here and I can solve it by simply graphing it on my calculator. So I take out my calculator, hit Y equals, and I plug in my original formula. So let's look at my original formula. So I have X, left parenthesis, 600 minus 2X, in parenthesis. I make my window. And here I have to think about, what X is. X is the side of this fence, and so I have 0 to, and the perimeter says, 600 feet, so I'm going to go to 300, because if this is 300, then this is 300, and then Y has to be 0, because if you add these up, you get 600, but 300 is a good guess. And then I hit zoom fit, and I'm going to get a graph. And it's a maximum, so it goes up and down, so I draw the graph here. So I'm from 0 to 300. And it goes up, it comes down. And the maximum's right there. And so I can hit second trace, and I go down to the maximum, and hit enter. And it's going to ask me for different things. Left bound, so I can use the left arrow if you want, and go to the left of the maximum, hit enter. The right arrow scrolls the little cursor over to the right, and now I'm definitely to the right. And just hit enter for a guess, and I get out the area. That's what I'm trying to maximize. So area is equal to 45,000 feet squared. And so this is the maximum area, and this is my value for X. Notice that while these two X's right here and right here coincide, these two Y's do not. Right? This Y stands for output, which is actually the area, right? And the input is X. All right, the next part. The next problem, right below it, it says, now if you need to enclose a rectangular area of 1,800 square feet along the side of a barn, what is the least amount of fencing you will need? So let's change this a little bit. So we have our picture, right? Still a rectangular area. We still have one side, a barn. But this time, instead of giving us the perimeter, they give us the actual area. So the area is 1,800 feet squared. I still have this as X, this is Y, this is X. And now it says, what is the least amount of fencing I will need? All right, so that's find min amount of fence. And if you think about this, right, the minimum amount of fence, that's no longer area stuff, right? Now that's perimeter stuff, right? It's what you would go to Lowe's or Home Depot and say, I need to have 300 feet of fence, right, to build a fence in my backyard. So for my equation, instead of finding an area formula, I'll find the minimum amount of fence, so a perimeter formula. And that's equal to x plus y plus x, because that's what I'm trying to minimize, the least amount of fence. So 2x plus y. I'm in the same situation as before. I would love to graph this, but I don't have one letter, I have two, so I can use the 1800 to get rid of the y. So 1800 is equal to, that's area, so x times y. And so y is equal to, well, to move over to the x, I just divide since I'm multiplying. So I take 1800 and divide it by x, and then I can plug in over here. So p is equal to 2x plus 1800 over x. Right, and now I want to solve. So the way I solve this is I'm going to graph it. So I take out my calculator. I hit y equals, and I want to graph this function, right, this formula. So I have 2x plus 1800 divided by x. Right, that's my perimeter formula. And I make my window. Now for my window, I'm going to go from 0 to, and now I have to choose a reasonable distance. So I have it set at 300. That seems fine to me. Let's leave it at 300 and see what happens. So I hit zoom, zoom fit. And now this is a minimum, so it should go down and come up, and it does. So I went from 0 to 300 feet for my x, and it comes down and then goes up. And so the minimum's right here, and I'm going to go find it with my calculator. So I'm going to hit the minimum button. So I hit second trace, and then go down to number 3 to find the minimum. And here, instead of using the left arrow and the right arrow, it says left bound. I'll just hit 0, because I know x equals 0 is to the left. And then for the right bound, I'm going to hit 300, because I know x max is 300, so I know 300 is to the right. And for guess, just hit enter, and out pops my answer. So x would be 30, so this would be 30 feet. And then y, which is not this y, right? Remember, this is the perimeter of my output, so the perimeter is 120 feet. So the least amount of fencing, right, P, would equal 120 feet of fence. And so that's my answer. And then again, you don't really need to test, because the testing actually is given by the graph. Make sure it makes sense though. So 120 feet of fence, I mean, that's fine with me. Same thing up here, right? Over here it's 45,000 feet squared. Look at how many feet came out of here, and the answer makes sense. All right, on the back side, all right, so this is the tough problem, so let's draw a picture here. It says a landscape architect plans to enclose 5,000 square foot rectangular region in your backyard. Should be with shrubs costing $10 per foot along 3 sides, and your house for the 4th side, find the minimal cost. Okay, so it's a rectangular region, I know that. There's 5,000 square feet, so the area is equal to 5,000 feet squared. We'll use 3 sides with bushes, $10 per foot. So let's just do some bushes here, and we'll just choose any 3 sides. It doesn't matter. I'll choose these 3 sides. All right, so these are bushes, and they're $10 per foot. And then along this side, it says we have a house. So I don't need to put anything there. This is my house. Right, so that's my house. And then I want to find the min cost. Okay, so let's go back and take a look at how this works, right? Find the max area. So I find the equation for area. Find the least amount of fence. So I find the formula I make is for the amount of fence, the perimeter. Here it says find the min cost. So for my equation, my formula, I find a cost equation. It's whatever you're minimizing or maximizing. And so I find the cost equation. And so I remember now this is going to be x, this is going to be y, this is going to be x. I don't need to label this side because it's my house. And I have to sort of imagine what would happen if I had 1 foot. Well, here I just spend $10. It's $10 per feet. 2 feet, right? 10 times 2. 3 feet here. 10 times 3, 4 feet, 10 times 4, x feet, 10 times x. All right, so it's 10x. Plus, once I have that idea, this is simple. It's just 10y for that side, plus another 10x for that side. And then, of course, it's $0 for this side because that's my house. So my cost function C is equal to 20x plus 10y. And I'm in the same situation as before. I'd love to graph this and find the minimum, but I have not one letter, but two, so that's where this 5,000 comes into play. So 5,000, that's the area, so that's x times y. I can solve this for y by dividing both sides by x. So y is equal to 5,000 divided by x, and I simply plug in here for y. So C is equal to 20x plus 10 times 5,000 over x. Right, just swap out y and this. And I might rewrite this a little bit. So this is 20x plus 10 times 5,000 is 50,000 divided by x. And I can solve this now. Right, the way I solve it is I'm just going to graph it and look for the minimum. So it should go down and come up. So on my calculator, I hit y equals. I clear all this stuff out, and I plug in 20x plus 50,000 divided by x. I make my window. Oops, let's make sure that was 50,000. Yep, I make my window. And so to make my window, I come back up here, and I think, okay, well, what can x be? Well, this is my backyard, so maybe I'll make it up to 100 feet. Right? My backyard is about 100 feet. All right, zoom fit it, and see what happens. All right, so it comes down, and then it barely comes up over here, so I think I need to go a little bit further than 100 feet. So let's go, let's do 200 feet, see what that does. So again, I'll do 200 feet, zoom fit it again, and it goes down, and again, that's fine, I guess. It barely comes up, and if you go out further, you can get a better picture, but I think that one's actually fine. So on this one, I went from 0 to 200, and it came down, and eventually you see it comes up. The minimum's right down here, so I'll hit the minimum button. So second trace, go down to minimum. So 1, 2, 3, hit enter. All right, left bound, yeah, 0. Right bound, I made 200. Hit enter again, and out pops a minimum. I'm looking for the minimum cost, so this is the x value. All right, so that's the 50 feet. And this y, remember, it's not this y. It's actually my output, which is the cost C. So this tells me that my minimum cost, C, is $2,000.